All right. I call to order this meeting of the Homebrew Robotics Club, September 28, 2022. And this one is special. It's our 20th anniversary of the HBRC Challenge, Phase 3. We do these meetings 3 times a year. So this will be the 60th HBRC Challenge. So it's quite a milestone. Anyway, so call this meeting to order, and first order of business is industry news. Anybody have any industry news out there?
I got some camp. Let me just throw it in the chat to everybody. NVIDIA had its big conference. NVIDIA Embedded had its big conference this past week, and they announced the NVIDIA Jetson Orin line, which is really the successor to the NVIDIA Jetson. And there's some good news, and bad news with it. If you go to the link, the good news is that the new NVIDIA Jetson Orin module, the base one at $199, is much more powerful than the previous Jetson Nano module, which is great. It provides a pretty low cost point to being able to do a lot. You just have a lot more compute power than you did with the original Jetson Nano, which was already impressive. And that translates into much higher frame rates for computer vision and faster inference for all kinds of machine learning stuff. The downside is that in order to play around with it, to the start, they want you to use their dev kit for their more expensive board, which is over $1,000. However, I expect that soon we'll see Seed or some other third-party folks make make carrier boards for the new Orin. So the downside, the tough part about it is when Jetson Nano dev kit first came out, they really put it up as competition for Raspberry Pi, and it was only $99, so it was very affordable. That is probably going away. It's not, you'll probably end up paying $300 or so, for the base model, and it does seem like that they're really abandoning trying to be part of the hobbyist network and are much more geared towards having the dev to industry and that kind of thing. However, when that stuff is available and you can get a carrier board, it will still be awesome to play around.
Cool deal. Any more industry news out there? I've got something. Dr. Ed and I have been following the RISC-V scene. And it looks like some folks, Acceleration Robotics, I just posted in the chat, are creating ROS-specific RISC-V chips. The RISC-V is open source microcontrollers, and it's very interesting because the history of microcontrollers are, Intel and AMD, building chips and selling them, and then ARM got the idea to license their technology so other foundries could build chips and so forth. But here's coming an actual open source committee, RISC-V, creating microcontrollers, and it looks like Acceleration Robotics is going to be, building like ROS accelerator specifically for ROS acceleration. So interesting stuff there. So from what I read, it's still not up to speed with ARM and Intel and so forth, but it's all very exciting and open source. So something to keep an eye on. Any more industry news out there? Go once.
Thank you. Thank you. Well, also from NVIDIA, They have made a lot of progress in 3D scanning, and they have announced that platform where you can just scan your place, have a 3D representation, and then you can train your models in the digital twin, which is the term they use for that thing. So then you have your space and you can just play with your virtual robot, train it there, just crash it or whatever, you can do it there until it works, and then implement it on real life. And I think that's also amazing. They have been a lot of progress on that.
So who is this?
Also from NVIDIA.
NVIDIA.
Yes.
Is that is
Are you
that
talking
their
about Bloomberg?
Isaac Robotics platform?
Yes, it's what they call digital twins. You just type digital twins NVIDIA, and they have been pushing a lot of research on there. Yes.
Thank you.
Crash your robot into an asteroid?
I guess yes.
Are you talking about DART now, Dan?
Just a little joke, yeah. That's cool.
Thank you.
Thank you very much. Dan, did you mention DART? Did you mention
I
the
mentioned
spacecraft?
it, but I don't have enough to say about it. Maybe you would want to say something about it.
No, I was just going to say that was super cool. If you didn't catch it, Google it and have a look. The other night we crashed a spacecraft into a small moon that was circling an asteroid. It's like this asteroid that's got this small moon circling around it, and we've been aware of it for 100 years. And a couple of years ago, NASA started building a spacecraft called DART, D-A-R-T, and sent it up there, and it hit that moon yesterday, spot on, and there's video of it hitting. And now, let's see, the observatories all around the world, looked closely at this asteroid and its moon, and made all the measurements and so forth, and are measuring it before DART hit and after DART hit. The goal being that survival, should there actually, and there's a movie about this, Apocalypse, right, with Bruce Willis, where
Don't look up.
if the killer asteroids headed to Earth, hit it and spang it off in another direction. So we should get feedback in the next couple of weeks as to whether or not we actually affected that orbit, and measurements and so forth as to how much we affected it, and maybe be applied to killer asteroids headed towards Earth. So that was cool. That's the NASA DART mission.
I mean, the remarkable thing.
So
it was
what's
an
really cool about it,
an autonomous device, craft the size of like the refrigerator, they say, or something like that, that hit something 7 million miles away, going 14,000 miles an hour.
Amazing.
it's amazing. They hit a target that they had never seen before.
Right.
So it had to pick up the larger asteroid and then autonomously figure out where the satellite of the asteroid was, and autonomously find it and track into it. So it's pretty amazing.
Very amazing.
But NASA has to put their great big rocket inside the hangar while the hurricane blows over. They are not all powerful.
Any more industry news?
I found an article on the from Agility Robotics, digital bipedal new robot. Have you seen that? It's I can share a picture here if you want.
Let me activate screen sharing.
Bipedal.
If you can drop a link in the chat, that would be good.
Yeah, here's the report. It's these bipedal robots. This is Agility, and this is titled "The Future of Robotics." But so some of it may not be really actually happening other than remote control, but but this is a pretty cool looking concept. And
It's grown arms. Last I saw, it was just bipedal.
right, this is the one, the chicken based walking with the knees forward like that, right? Or no, actually it's not chicken, but yeah, that seems like they've made some progress in that agility, and for bipedal, and it's looking better and better. So
Can you drop that link in the chat, Jim?
yeah, sure, I'll do that.
Any more industry news? All right, let's move on to club news now. First thing is we need a presenter for next month. So anybody that's interested in doing a presentation, either contact Stephen Williams or myself, and we'll see what we can do. Presentations is everybody's job, okay? Stephen Williams is our presentations chairperson. So if you're interested in somebody in industry doing a presentation, contact them, see if they're available the last Wednesday of the month. Don't book them yet. Contact Stephen or myself and make sure the space is available. But presentations is everybody's job, and we need a presentation for October. So we'll discuss that at the business meeting the first Wednesday. And everybody's on the HBRC mailing list, right? That's where you get all your news and so forth. All right. What I need
Camp,
help with.
I have a few announcements.
Shoot.
Camp, Camp.
Go ahead.
Okay, yeah, I have a few announcements. So we have some new people, and I just wanted to say a few words about the club. So am I on the camera? I see my body is, not my head. Okay.
I got you spotlighted.
Hold the phone up a little more. Oh, that's
Well, I've got
okay.
the main camera. I can do the other one.
Yeah, that's okay. They can see my back. So, okay, so the gentleman on the screen is Camp Peavy. He is our club president. I'm Dan Tuckler. I'm the club treasurer and secretary. Al Margolis is, I don't even know what your title is, but he's in charge of everything. He does the website, he does the meetings, does all kinds of other stuff. So
Al's in charge of awesome.
in charge of awesome. So just a few words about the club, because there's some new people. And honestly, a month ago, we had about 15 or 20 new people. And for various reasons, we have just a few, but that's good because we're trying to grow the club constantly with people that really care about robots. So there's an information sheet here that you can pick up that just says a few words about what our club is all about. As Camp just said, there's a discussion forum and mailing list that's essential. You can go on there, sign up without being a member, participate in discussions about everything to do with robotics. And just read the discussions or participate actively as you wish. We have every meeting like this is on YouTube. So you can go back and look at old YouTubes and learn all kinds of interesting things and see presentations. You know, Marco's first presentation of his robots are up there, everything. We meet every month on the last Wednesday of the month, except in December, we take a month off. On the 3rd, 6th, and 9th meetings, we have these challenges like we're going to have tonight when we get done with me talking. We're going to be showing some robots. The other nights, we have very excellent speakers of all different kinds, some industry experts, some demos. It's usually very interesting stuff. We start out with a few announcements like tonight, and then we dive right into the presentation. We are hosted by Maker Nexus, as you know, because you were able to walk in the door. There's a flyer here about Maker Nexus. I'll put them here on the side table so you can learn more about this place. They're kindly hosting us. Let's see, I think that's about it, except I'll just say about membership. Membership is optional, but it's encouraged. It's $10 per family per year. Kind of the best deal in Silicon Valley. Inflation hasn't hit it in a long time. Membership keeps the club healthy. Okay, so if you feel like being a member, you can sign up for the remainder of 2022, or you can wait and sign up for 2023. but that's encouraged just to keep our membership rolls strong. Al, what did I forget? All right, we have I don't know where the bathrooms are. Walk around till you see a bathroom. There are 31 people online. So this used to be an in-person meeting and we'd get 60 or 80 or 100 people all showing robots, and it was fascinating. And then COVID hit. And during COVID, we went to an entirely virtual meeting. And the funny thing is we started getting people from all over the world. We had people from Russia, Liverpool, a few people from Canada, where else? Just
Florida.
all over. A couple of people from Nigeria. And it really made it much spicier and more interesting just to have all these different points of
Those
view.
Canadian
Now-
guys.
Yep,
Those
yep.
can,
Now we're navigating. This is our third meeting that's hybrid. So we're learning, you know, like how to conduct a meeting without turning your back on the camera or turning your back on the room full of people. We're still working on it, but we're getting there. Spotlighting the right camera, but we're getting there. So it's kind of cool because we have 31 people online. We have, looks like about 15 people, 12 people in the room. I can't count. But it's a pretty healthy crowd and we're just going to keep growing it as a hybrid meeting. So I hope you enjoy it. That's all I got to say. Any questions about the club at all? Cool. Back to you, Kent.
thank you very much, Dan. All right, the next segment of the meeting is what I need help with. Does anybody have a specific question, something they need help with? What did we figure out the other day? We were working with the bot vac and command velocity. There's nothing there. Anyways, okay, so everybody knows everything and doesn't have any questions or anything, right?
Hey, the camp, I want to put it out there that I'm looking for a job in robotics.
Thomas Messerschmidt, builder of Simone, is a righteous robot dude. So he's on the mailing list. So somebody that needs robotic support service, Thomas Messerschmidt's a good guy. How about that, Thomas? All right.
Yeah, and I'm good at building prototypes.
Yeah, and he does AI stuff, so that's good. The next thing is, well, okay. Here we are, the show and tell segment, the best part of the meeting. And this is our challenge meetings, is that it's all the best part of the show, nothing but show and tell. So I think we've got about 15 or 16 robots to show here. In 2003, a group of us were lamenting the lack of building in the club. And we observed that the building coincided with contests. We had done a line following contest and a maze busting contest at the time. But these involved fixtures that had to be set up and stored, and it was a contest, and you had winners and losers. Somebody was inevitably unhappy. Your tape was shinier than what I used, or gosh, I thought the gates were going to be wider in the maze, something like that. At the time, we were meeting at the Castro Middle School library, and there were tables everywhere. And we thought, let's do tabletop soccer, which is non-trivial. You know, we thought, well, we could put a net around the table so if the robot falls, it could catch it and that sort of thing. But no, that would be setup. That'd be something that you'd have to, you know, carry around and have. And that's when it was born, the table bot. A table bot is a robot that survives, lives, and plays on a table or pays the price. Since then, we've expanded the table bot challenge to be the HBRC challenge, and we've introduced other three-phase challenges. Specifically the floorbot challenge, the armbot challenge, and others. And then there's the catch-all category, the run what you brung, where the concept originally was you're to build your robot into some state of finished. You know, our stock in trade is functioning robots, okay? But works in progress are good for partial credit. We wanted you to show up in the phase 1 meeting in March with a robot that's finished to some degree, and then you were to enumerate your phase 2 and 3 goals, and we check back in August and September and see how you did. Of course, none of this worked out, and pretty much, you know, folks show up with what they have or what they don't have. Like I say, works in progress are good for partial credit. But what I've observed with these challenge meetings, and many of us have experienced it here, is even if you're not showing your robot or you know, things didn't work out right, is that because you have these challenges, because you have this deadline, okay, without a deadline, nothing happens. But because you have this deadline, you put time, energy, and effort, money into your robot, you know, to actually get it going, so you have something to show. So that's the importance of the challenge meetings. It's a deadline, it's a line in the sand. This is our 20th anniversary of doing this, and this is phase 3. As I mentioned before, we've had 60 of these meetings so far. So without any further ado, let's just get into the HBRC challenge here. Now I've got a list of names, and I'm going to paste this into the chat, and we'll try and go in this order. Basically, we're going to start off with folks that are online, and then go to the folks that are in-house, and then we'll go back online. And so I may need some help in trying to keep the order here, but let's see who's up first. John Carlini, you out there? Turn on your microphone, John. John Carlini, John Erickson, you're on. Unmute your microphone.
Yes, what do you need, man? Sorry about that.
Tell us what's going on.
Really not a whole lot. We're working on Zeno over here. As you can see, he's got a new head.
New arm.
Gonna be doing a new arm.
Gonna be linear. Gonna go up and down. I got a new circuit for Zeno. I'm putting Adreno on him with the Mega board, and I got the H bridges running them.
How do you spell Zeno?
Zeno.
Okay, hang on a sec. Let me put a spotlight on you.
Spotlight.
I need to take the spotlight off of me.
Yeah. Take the
There
spotlight
you
off.
go. Can you pick up the computer and we can get like a glamour shot there?
The computer? Oh, there you go.
Hey, Carlini, you went to Burning Man with your robot, didn't you?
Yeah, this is one over here. That
That's
guy
Demon,
there.
right?
Yeah, well, he had a different name, but I don't remember it because you know how Burning Man can be.
Show me Zeno.
All right.
These are remote control entertainment robots.
Yeah, but I'm trying to put a circuit on them that will attach to the side here, and then I also have a computer on here that'll run the Adreno.
Can you see that?
I can see that. Get a picture of Erickson with Zeno's face. Erickson, stand next to him. There we go. And you guys make bases, right?
Yes.
Okay. If you need a good robot base, contact John and John. They'll get you set up. Let me get a picture of Demon over there, Carlini.
I don't know how you're gonna get with it.
That's good enough. And what's the middle one's name?
Let's see. This one here, that's Zybot. Oh, let me look. Like there's Zybot.
Let me give
That
me
one
a
is
good,
Zeno right there.
yeah, give me a good shot of Zybot. All right, good enough. Thank you very much.
And then if you want to get one of the Mr. T, old school.
Mr. T.
You remember Mr. T, don't you?
Mr. T's a classic. Mr. T's a close.
Open now, man.
Mr. T's a close relative of Rocky.
Yeah.
All right, guys. Thank you very much.
Cool.
Okay. Next up, we've got Scott Monahan with Robot.
All right, can y'all hear me?
Let me spotlight you, Scott. Hang on.
Okay.
You are
All right.
spotlighted.
Cool. Can you guys hear and see me okay?
Yes.
Awesome. All right. So what I'm gonna try to do is, this is actually inspired by Big Orange's Floorbot Challenge 1 and 2. I'm trying to do the same thing where for a long time, I've wanted to get Robot to be able to follow me. And so I set that up. And because I've had experience with failing live so many times, I recorded it the other day. So I'm just going to play a video showing what I did. And you guys let me know if I made it or if I got close or what. All right, so let's see here. So what I do is I wake it up with its wake word. I tell it to follow me, and then it uses the MobileNet SSD object detection to look for a person and follows that person around. And so the Floorbot Challenge 1 is to have it go back and forth in the room. And this one, I've got it going all the way around the kitchen and back. And then Floorbot Challenge 2 is to locate an object. And in this case, I was the object that it is tracking.
Does it know how far away you are and that sort of thing, and stop in front of you, or is it doing?
Yeah, it doesn't have any obstacle path finding, but it will stop if it gets close to me, and you'll see that at the end with my bare feet here.
So it is doing depth, or actually, yeah. How does it measure how far away you are with just one camera? Or
see this right here? That's Robot's time of flight laser sensor, and that's what it used for it. But that's it.
Nice.
What do you say, Chris?
Well, that does qualify for a Floorbot level 2.
All right. I'm
Okay,
really
Floorbot
excited.
level
Thanks,
2.
everybody.
The Floorbot Challenge, and you can go to our website and look up the challenges. Floorbot Challenge has 3 phases. Phase 1 is to go from one end of the room to the other and back. Phase 2 is to find an object in the room, which is what Robot has successfully done. And phase 3 is to fetch that object. So Robot's going to have to grow some arms or something.
Yeah. Well, we'll see. We'll have to surprise you with something next time.
There we go. Thank you very much. Okay. Next up on our list is James Fellon. James, you're on.
Howdy. In the trial last night, my internet was so unstable, my video didn't do well. So what I'm going to do is drop a link to the YouTube into the chat so that you can see this is the open source Mars rover that was released by NASA. I think they started working on it in April of at the end of July. It's gone through several iterations. It started off as just a community outreach, basically a marketing project from JPL, and they assigned it to a couple of the interns, who whipped it together in a matter of I think about 6 weeks using standard off-the-shelf parts. And released it as a hobbyist outreach thing for JPL and NASA. So they released it and created a community of open source rover builders. Last time I looked, there were about 130 or more around the world who are working on the open source rover. It's modeled after, I think, Curiosity. It's costing billions of dollars. It was supposed to run about 2,500. I'm sure we've put in at least $3,000. It's been a continuing evolving from Python code to ROS 1, improved to ROS 2. They've changed the printed circuit board, improved the motors, improved the steering motors. So it's just an ongoing evolving project. And what we hope to do in our robotics club here in Houston is to put on LiDAR and a depth camera and make it autonomous. So there you go. And rather than have me give you my really bad internet video, you can see it online. And that's it for me.
Sorry, I'm muted. James, your video is playing. You can narrate it.
Robot is I called Fidelity because it's as close as possible to the original NASA JPL specifications. My current version is called Audacity to be as bold and inventive as possible, building on the original NASA JPL plans. So what you
Very
see there
nice.
on the top is the bop to stop button and an LED screen, and I've eliminated both of those.
Very fine. Thank you very much, James.
And
James
it's spent
comes
time in
to,
Houston, so I'm going to leave you all.
all right, buddy. Thank you, man. James comes to the Ross meetings and so forth. So he's an avid robot builder. All right, who's next on the lineup here? Ross Lunan from Canada. Ross, you're on.
Okay. All right. Hi, everybody. So I'm showing off the Nito turtle as designed and defined recently by Camp PV using code that I guess it was original that was Ross 2-ified by Jim Nugent, based on stuff that goes all the way back to Fergie and all those folks. So here we go. I've successfully loaded ROS 2 Humble on Ubuntu 22 onto a Raspberry Pi 4, which is lives in the dustbin of my 10-year-old XV11 that I bought on eBay. So let's see, I need to press this button.
Do you want to share your screen, Ross?
Yeah, there we go. Okay, so what you're looking at is there's supposed to be a camera here. There it is. Can you see this?
Yes.
Okay, so this is a quick tour then of the right. So that's the XV11. How does this work? Oh, that's why. Sorry, the XV11 with a Raspberry Pi and a battery pack plugged into the diagnostic port on the side, and that's the webcam that I referred to earlier that's also plugged into the Raspberry Pi. I'm just going to put this over here. And this. Okay, the main screen here. This is the image view presentation that displays the video message that's transmitted by the V4L4 ROS package that's publishing the
That's video for Linux.
Video for Linux, which works surprisingly well. And ta-da is the map, the SLAM navigation map that is a map that I created earlier today. So very simply, I guess I push this button here and go like this. Or here. And there it goes tearing across my floor.
Hey, Ross, go to panels.
Okay.
Up in the upper part, panels. Not your displays, panels. And go to navigation 2 down below. Oh, okay, you've got it there. Do you see the waypoint nav through poses mode at the bottom?
Yes.
No.
Yeah,
Okay,
right.
click on
Yeah,
that.
they're down here. There
Yeah,
they
click
are.
on that waypoint. Yeah. Now go to your nav goal, nav 2 goal, and click on one end of the room. Okay,
Aha.
click on your nav 2 goal again, and click on the other side of the room.
Going like over here.
Yes, sir. Okay, and click nav goal one more time, and take it to the other room, other side again. Click. Other
Okay.
side. Yeah, now click on that. Okay, now click start waypoint following.
All right.
Well, don't say all right yet. It's not all the way finished. We'll see if we can't get you a Floorbot Challenge Phase 1 from Chris.
Okay. Fair enough.
Are we having fun yet?
This is the coolest thing. I have to give a huge amount of credit to those folks that created the scripts in the first place.
Yeah. Well, that would be Mike Ferguson in 2010. He wrote the original Nito package. And then the SD Ross group, including Ralph Gnock and Alan Fetterman and Tony Pratt-Canis, and added the URDF and the launch files. And then finally, James Nugent updated the code to Python 3 so we could run ROS 2. And so here's ROS 2 waypoint navigation. And if it can make it to the other side, I think you may have a good case for the Floorbot Challenge Phase 1.
And the camera is nicely following what it's doing.
There you go.
It's 640 by 480. So it's I guess obviously pretty good resolution. Doesn't seem to bog things down. The video you're watching in the bottom right, that's an iPhone app that is actually running on my Mac. This is just a window on my Mac. It's got nothing to do with ROS.
All right, you just did a Phase 1 Floorbot.
All right.
I got you down for Phase 1, Ross. Very nice.
That's great. You don't know how much anxiety I've been through the last 2 days. So glad it worked with much help from Michael and Cap. So thanks, everybody.
Very nice. Very nice. That's Ross Lunan from Canada, folks.
2 S's.
2 S's. All right. Scott Horton, are you out there? Hello, Scott Horton. You're not muted, are you? Calling once, calling twice. Scott Horton. Okay, Scott Horton out of Texas. Didn't make it today. Brian Kosky with the Black Adder.
You bet. How's my audio?
You're sounding good, buddy.
Okay, great. All right, so Black Adder, yeah, that's a snake robot. So this is basically 10 servos linked together horizontally and vertically, alternating horizontal and vertical. And this is an experiment on my part just to try to get all the different ways that we can get this moving, basically. So there's like a worm motion and the sidewinder motion, rolling, helix, climbing type of thing. So I actually, what I'm going to put in the chat here, the link to the short video, the 30-second video. I don't know if it's easier for you to play that, Cap, or myself, just to start.
I'll get it.
Good. So great. So what this is really a short video, 30 seconds, just to show the things I just described, you know, how the different types of movements can happen. So while we wait for that to go, then I'll do a live demo of a helix climbing motion, which is basically it's going in a type of a circle, and then it will be doing some rolling around itself. So yeah, this is Blackadder. Right.
It looks
so
like the
that's
one you were holding only had 8 servos.
no, this is the same one. Yep, same one. So there it's going sidewinding now, right? It's horizontally and vertically, waves going through it, and it ends up being a sidewinder. And this is different frequencies of horizontal and vertical motion. It's a sidewinder, but it's turning, and this one's a rolling motion, right? Which is actually the most efficient way to move for this type of thing. Yeah, and that is it for the video. So now we'll do a little demo of.
Sorry,
this
hang on.
itself. Yep,
Let me get you back.
no problem. So since then, one thing I wanted to do is try to get a climbing type of motion out of it. So I'm powering up. So this will go slowly into a straight line, and then on the arm here, basically it will go into a helix shape, and then it rolls around itself. Right. So you can, depending on how tight you make the grip, you can basically hold on to things and, you know, climb or crawl. But basically, it's going in a circle around itself. But oops, I lost a joint. This happens quite a bit, actually. One of the things I was trying to do with this is actually to change the parameters for all this stuff is a bit of a chore in the code. So I was trying to externalize that and basically, you know, set up some of those parameters to be controlled with potentiometers, just to get a better idea of how the movements work. See, so one of the joints just broke there. That was by happenstance. I built this thing out of foam board initially, just to try to get the shape correct and the dimensions correct. But it turns out that that's a very good thing to do, because when you're doing bad code and it collides with itself, the first thing to go is like the hot glue or the foam board instead of the servos. So it's like having a built-in mechanical fuse that you can just fix with hot glue, you know. So my servos haven't been damaged through all this stuff, and I just have to keep replacing the foam board and the hot glue as I figure this stuff out. So that's a lucky experimenter's side effect, I guess. So that's it for
very
me.
cool, Brian. Thank you very
Thanks.
much.
If you don't already have it, that qualifies for a phase 1 robot arm challenge.
Very good. Thanks.
Is there only one servo in each joint, or is it 2?
Yeah, it's one servo. So here, I'll try to get a little bit closer here. I'm gonna have to power it off, or otherwise I won't be able to bend it. Hang on. So let's see here. So like, for instance, this is just bending this way, right? And then the next one is bending in 90 degrees to that. So altogether there's 10 servos, but there's 5 in each, 5 vertical and 5 horizontal servos just alternating. Yeah.
Now for the algorithms, do you model after like a real sidewinder, or after biology? Did you look into how a snake works or anything?
Well, this was actually got my interest. There was a paper written about 10 years ago, a guy's PhD in I don't know, he was South America, I think. And basically he was doing experiments to figure out all the different ways this type of robot could move. And so algorithmically built all the different potential combinations of movements and summarized all this into his PhD thesis. But yeah, it's once a gate is moving, like in the video, there was, well, even the crawling motion up my arm, right? All that is you set each individual servo to go in a sinusoidal movement the same way all of the time. And the way you get different movements, different gates, is that each of the servos in a chain is offset by a certain phase differential, and the horizontal and vertical servos are offset by a phase differential as well. And that's it. each servo is just going sinusoidally itself once a gate is set up. It doesn't look like that, but that's all it's doing. So it's the combination of it that makes the difference. Yeah.
Very cool.
So cool.
Thank you very much, Brian.
You bet.
All right. Next on the list, we're going to start to go to the local folks at Maker Nexus. I've got Shanab Bose. How are we going to do this? Who should I highlight?
If we make the table this way, then that can look at it and the people out here can see it. How's that sound? Why don't we grab that in and move it over this way a little bit? And then it'll be angled, just your end. Okay, well, I've got the camera spotlight.
So this is going for TableBot phase 1, right?
They'll be looking sideways at this so they can sort of see it and they can see the room too. And you can still do that.
Shanab, you're going for TableBot phase 1, right?
Yeah, for now it's just phase 1. So my TableBot, I think phase 1. It's a AT-Tiny base TableBot. It has, I think, 3 sensors, 2 at the front and then 1 at the back. The back sensor for now, so my robot could go without the back sensor. It's there for a precautionary case. And I think back here is my circuit board. The wire's a bit of a mess, but it's under
That's homework
all of the
style,
wires.
Shanab. You're doing well.
Yeah, I could just give a quick demo. There's also quite a small problem. My robot doesn't go straight. So every time I switch on, it just goes to one side since one servo is going forward and the other one's going backward. I think that's my theory. And the one going backward is weaker. But
Okay, that's one end of the table. And that's the other end.
All right, official, phase
Very
1.
good. That's a TableBot challenge, phase 1. Very good, Shanab.
thank you.
So next time you can come back and have phase 2 and 3. We do show and tell every month. So bring your robot and you can show it off at show and tell, okay?
That was awesome.
Thank you.
Hold on.
And next up is Suresh. Suresh, you out there? Sure learn. Suresh, you out there? You're not muted, are you? You're supposed to be on
So
site.
locally, we have Mark and Marco, I think. Anyone besides Mark and Marco?
LS
All right.
is in the list.
Yeah.
Hey,
well, but
Suresh, yeah.
Are you online, Suresh?
I'm online here. Yes, I'm
Oh,
watching
okay.
what
You
you
got a
guys are doing.
demo?
Not today, Camp. Not today.
Oh, okay. I
I'll
thought
have
you had a
some.
demo today. I got you signed up for a demo, dude.
Oh,
Don't you have a robot named Sif? Is there a robot named Sif out there? All right, never mind. Mark Johnson, have you heard the word?
Word is brought. So this is the, I was gonna stand here so that way I can sort of face everybody. Yeah, the mic is good. This is the free Nove little robot dog. So lacking a lot of interesting things to say. I just call it Robo Doggy. And there's the head, little servo there. Each leg is 3 of the 12-gram type servos. And then I've been discussing this online a lot, so you can see everything there. I managed to calibrate it. And also it has 3D printed feet
and the feet are sort of soft, but I found not soft enough. So get a little bit of texture on this board. And you go through a calibration process with these little stands, and it's worked out pretty nice, actually. They did a good job. A lot of assembly time to get all the servos and everything going. Then on top is a much overused little circuit board that does many things. It allows starting up of a Raspberry Pi and a Python script, then jumps to the actual code you want to run. I've used it many times. The other thing it has is a RF controller from one of these little tiny little cars, HO scale cars that are radio controlled. So here we have the MTPC, which stands for Mark Toys Precision Controller. And I want to emphasize precision, not. So anyway, it just does some kind of, not supposed to shuffle, it's supposed to go forward. But then again, that's what demos are all about.
We love the live demos, Mark.
Okay, it's just barely making forward progress.
Okay.
It does really well backwards.
Okay.
So
if you go from one end to the other, you might.
yeah,
be
so
able to
look at that.
talk
It goes
to
really
phase
well
one.
backwards, and I think it's because the feet are angled backwards, and it naturally tends to kind of favor moving that direction. You ever had one of those little football games that you put up all your pieces on the vibrating table, and they all have little plastic things? You turn on the thing, and of course they all go. That's what it was doing. My plan. Oh, then this has a Raspberry Pi 3B. The code that they have will run on a 3B or a 4 if you can find it. And this is running the Ubiquity Robotics kernel. The Ubiquity Robotics image. So it has all of ROS 1 on it. Our newer images are going to have ROS 2, but that's like a floating hockey stick. So we're going to have this thing connected up to the camera, which is a standard Raspberry Pi camera, shoots out the front. And these are a couple of sonars. I'm going to strip back the sonar node to be a 2 sonar node, which is really as simple as deleting stuff. Then we'll have ROS nodes on top of this thing and have a few sensors and so forth on it and a video feed. So that's the plan. Those parts aren't here yet. If anybody wants to ask any questions about it, I brought some feet for James, but he's not here. So, so you got credit for that, James. All right. And that's it. So,
Are you guys gonna share the STL models of those feet?
oh yeah, I shared the STL models of the feet online. I also shared the STL models of something that I thought was pretty darn valuable to have. And that is simply a taller stand.
I have it.
The taller stand is handy because when you put a taller stand on there, you can experiment and none of the feet will ever touch. Okay.
Ah.
So that's really good for prototyping your algorithms and stuff like that. Both of
Yes.
those are online STLs.
So I have one to be made.
That's
It
very
takes
cool,
a lot
Mark.
of, the build takes a long time.
And what that you had your bootstrapping board on there? What did you call that?
Okay, that's on my GitHub. I can put some information on that on later so I don't use up too much time here.
Oh, but
It's a nice little Python program, does all kinds of things. What it has is a little auto start switch that if you set it, it looks for a particular file and it starts it. So in this case, it's starting my modified code of one of the scripts they had to then listen to the RF control and move forward and so forth. And then it has another one, which I'm going to hit right now. And it'll go into a reset and do a clean shutdown all with just a single switch. So you don't need a whole interface and all that stuff. It'll do a full shutdown. And that's the features of this other little monitor I have. It's like a Python system monitor that I start from root, and it fires up in the background and runs all the time. So it's waiting for the shutdown switch or whatever, and it starts your own code. It's a handy thing.
Nice.
Started with FiddlerBot.
FiddlerBot, world famous FiddlerBot.
FiddlerBot.
All right, Mark Johnston, ladies
Yeah,
and gentlemen.
no, this one's not going to be Fiddler Dog. Yes, sir.
Behind what do you call the servos, right? Doesn't it help you to move forward easily, like more stably? You have 4 servos, right? This is no. Okay, so at the okay, so in the hind legs, right? Yeah. If you throttle them a bit, would it not help you to move forward better because you are sleeping right now?
So there's going to be tweaking of the walking algorithm to make it walk better. Absolutely. Yeah, what I have now is pretty crude. It's just, it's scraping too much and stuff.
Mark Johnson,
I
ladies
had
and gentlemen.
everything ready for the meeting.
All right. Next up, we have Marco Walther. Marco, I assume you're going to talk. I assume you're going to talk a bit about maybe the botnik that we had last month.
Yes. Am I on the microphone?
Yeah, you gave me a video. Let me
Okay.
get that.
That's fine. Okay. Yes, I have actually no images from last 2 weeks ago, Botnik, but I have
I'll find them.
a little snippet.
I'll find it.
on-
Here's your Endecker video. Okay, let me share the screen.
I can try to play it here. I have it locally here. Let me see if I can play it here.
Oops, sorry.
No,
Pooey.
wait.
Sorry, let me unshare the screen.
Why is it not?
You want me to play it?
It doesn't let me do it. So can you play it?
Surely, one moment.
Somehow, usually I can just share one application. It didn't work this way.
He asked you not to call him Shirley.
Okay, so that's actually about 5 years worth of video from different iterations of the Endecker over Magellan rover. So those were the very first attempts to autonomously drive around the parking lot in 2015. And yeah.
Robo Games.
So still without.
Awesome.
So Robo Games.
Good times.
Yeah.
Good times. Nice.
Yeah, it made it all the way to the first cone, or
How
actually
many
the
gold
second
medals
one. The
did you
first
get
one
in
it's
Robo Magellan, Marco?
Sorry?
How many gold medals did you get in Robo Magellan?
2.
2? Very good.
Yeah. Yeah, so that was the last run. And there I forgot to turn on the camera at all. So the Entdecker is running ROS on a little Ultra U3, and it has a camera node. And here it was running without that camera node running, and so it couldn't see any any cones. So that was 2016. Uncut grass and wet, and I'm kind of stuck there.
Oh man, you're stuck in the weeds.
Yeah. And eventually it will.
Oh, this is the day it rained.
Yes.
Notice the plastic bag. That's hilarious.
Yes. It made it to that cone, but then it stopped. Yeah. So that's the last run. And that's basically straight for the goal cone. And you will see what happens there. So because of all the
Oh, that's awesome.
All the problems with the grass, I had to
This is Entdecker 2, isn't it?
turn up the power. Yeah, that's Entdecker L, the current version. So that's my first test run on very bad terrain. And it can handle everything pretty much. And
I know
so
those
yeah,
people.
that's now a combination of 3 runs. The first run hits the first goal cone.
That's a camera on the robot?
Yes. And so, but then it gives up at some point. That's the second run. It ends in the tree. And that's now the last run. And it actually misses the first cone, but takes this one and the next 2.
That's awesome.
For getting started in this, is there like a is there like a entry level or recommended starting point to do Magellan type preparation building?
What do you mean by starting entry point?
Oh, I mean like references, how to get started in building a Magellan, a robot that can tackle.
I had that is in Sierra College in Brooklyn, I believe, or where is it? Up there, somewhere up there. And so it does nicely on the 3 cones. Now it hits the little wall. Yeah, so even with GPS RTK, buildings are not your friend. You get so much
Oh, there's
multipass
rail tips.
problems. So that is
This looks like Baylands. This
Robotnik.
must be the first botnik.
Yeah, that's the first botnik. And so yeah, that's pretty much the end.
So Marco, there was a question from somebody online. So is there a kit or some kind of easy way to get into Robo Magellan or some kind of starting?
There is no kit. I did a presentation on it before here in the HBRC, and that presentation is still online.
That's on one of YouTube, so that would be a good place to look. And they did a really good job of talking about lots of things to watch out for.
And so yeah, that's online, or I have the PDF still somewhere. And 2017, I think. Yeah.
So somebody looked at 2017.
2017, I think before probably October, November timeframe, 17, something like that.
Okay.
There's going to be a Robo Magellan event at Robo Games, April, what, 3rd to the
Yes,
5th?
Robo Games.
So build your Robo
Robo
Magellan.
Games are open for registration.
Hey, Jim, you were asking about a starting place. Here's my 2 cents, is you've got a target coordinate and you've got a GPS on board. If you compare your target if your target latitude is higher than your actual, you need to travel north. If your target longitude is higher than your actual, you need to travel east. So that tells you what direction you go in, that direction, avoiding obstacles, and you will get to the GPS coordinate.
Right. Yeah, I just meant like, yeah, I'm sure that talk he gave is really a good starting point because it's covered, you know, back in 2017 or so. So I'll look for that in the archives. Plus, yeah, online.
I can find the date as well. I put it somewhere.
Very nice. Thank you very much.
Yeah.
Great history.
By the way, that qualifies for a phase 2 floor bot.
January 2017.
Are you handing out
Yes.
certifications, Chris?
I just did. That was a phase 2 floor bot.
All right, Marco, we're going to give you a phase 2 floor bot for Indecker L2.
And that's just a little ROS 2 demo. Sabi is now running on ROS 2.
This is Sophie, right? SAWPPY.
Yes, and it lost one server right now.
Hey, can we get a glamour shot of you and your robot there? Get in the picture. Can you get me a picture of Marco and the robot? There you go. Act like you're having a good time. Thank you.
That's it for me.
So, hey, Marco, so you're doing ROS teleop twist with your transmitter there? Yeah, it's ROS though, but you're using the teleop with the transmitter, right?
It's basically a joystick right now. Yes.
Yeah. Okay. Cool.
So
Thank you very
it's using
much.
the joystick node and I emulate a joystick.
Marco's been big help at the ROS discussion groups. Command velocity is expressed in meters per second, the linear velocity. The angular velocity is radians per second. Did I get that right? Thumbs up, yes? All right, guys. Moving right along.
So in case you guys didn't hear it online, Marco's talk was January 2017. If you want to learn all about swapping.
Thank you, Dan. All right. Is there anybody else? There in person with a robot to demo?
There are no more robots to demo in this room. There's a rocket club down the hall, though. We can maybe see some rockets. I doubt they'd send them up though.
We got our hands full here. Next up, Thomas Metzerschmidt. They'll let anybody in the building.
Hold on, I got to plug my phone in. It's ready to die. The battery is dying. All right. So I got 2 robots to show. We're gonna do the easy one first, and then the more difficult one in a minute. So, a few months I went to Disneyland, and when you get popcorn in Galaxy's Edge, you can get it inside one of these mouse robot things. And obviously it's just a popcorn holder, but I added some motors and some sensors and an Arduino board, and I made it functional. So with a little luck, it should work. You have to And the battery just popped out because I don't have a battery cover on it. Hold on a second.
You got 4 more minutes.
I know. All right, let's see. Gotta turn the darn thing on and put the battery back in and turn it on. Yeah. All right. And of course, they get scared. If you scare it, ha! It's not as fast as I'd like, but you know.
We're hard to
Okay,
impress.
that's
We're hard to impress, but easily amused.
yes, that's amusing.
Hey,
and the next robot.
Thomas, before you go too far, can I get one glamour shot of you and the mouse repair droid?
Sure, hold on. Sit on the floor here.
I like your dog.
That's my dog.
He doesn't
Hey,
know
that's a
what to
pretty
think
good
about
looking
the
robot
mouse
there, huh?
repair droid. Oh, that's beautiful. Thank
How's
you
that?
very much. Moving
All
right along.
And moving right along, we got the masked robot here.
The masked robot. Oh no.
Oh no, yeah.
Isn't there a TV show about that? The masked robot.
I don't remember. Yeah, I gotta turn it on here. I need another hand. That's the problem. Let me put it over here.
Just giving you a hand there, buddy.
I think it's falling over. This battery is low.
What is that display?
It's
He
telling
seems to be
everybody.
complaining about his battery.
It is complaining about the battery for sure. It'll keep doing that until I connect to it.
And mine does that too. Always complaining.
There we go. Okay.
Can you get a little closer? A little closer?
So it's not very smart at this point. And I use the mechanical wheels because I just love mechanical wheels. They go side. And so I figure, well, if it can go smooth, it can go in a circle. Let me move it a little bit this way. So because I'm running out of room in my living room, I mean my kitchen here. So I figured if it could go in a circle, so let's start with a circle.
You got 2 minutes left.
And it stops every once in a while. And there's a reason behind that. And we'll get to that at the next event. I figured since I like circles, I might as well try squares. And so I had it do a square dance.
No.
I just need the music and the dozy do guy going.
There we go.
Thomas, was it? Yeah, it has the Omni wheels. Was this from what company makes those that chassis parts? Or
Oh, this very famous company called China.
I mean, or did you just order? You didn't order like from you know, one of those like kit the company that makes. I
No,
think
it's not a kit.
Or
It's not a kit.
You're thinking,
I ordered the
you're
wheels
thinking
from
of
one
Acro-
company, the
you're
chassis
thinking of
from
Acro
another, and the
Robotics,
motors from a
Jim.
third.
Hey, Thomas, you think we can manage some kind of glamour shot there with the masked robot?
Sure. Let's see if I can turn the, well, I gotta shut off the motors. Hold on. The brains of this thing are on my laptop. Stop there. Everything stopped. Oh, you want me in the picture too, huh?
I just need some kind of glamour shot to remember this glorious occasion.
Okay, how about like this?
That's perfect. Thank you very much. Thomas Messerschmidt from LA, folks. Or Riverside, close enough.
Close enough.
Maris Davis.
Hello.
Dancing robots, you are up.
Okay. Well, I'd like to share my screen because I have a video. Let's see. Spotlighted. Okay. Great.
Right on.
Yay. Can we hear the sound?
Yes.
Cool.
Yes. Very entertaining, Dee Dee. Keep it going. Keep it going. This is what I found the dancing robots that make it there and stuff. Perfect. Everything. Thank you. Thank you. Dee Dee.
Almost there.
Yes, we are amused. We are entertained. More than amused, we're entertained.
Almost done.
That was awesome.
Oh, thank you. Very cool.
Tell us about your robots, Dee Dee.
Oh, well, yeah, it's Arduino Raspberry Pi with the Curry bot, as mentioned in the video, and it's running Python. That's doing all the videos on the screen, and actually, there's two of them. So I'm actually getting ready for a mini maker fair next at beginning of November. One of our members, Elise, is holding it in South San Jose. So it'll be cool to get some interaction
What's your group? What's your group in San Jose?
Well, normally I work with the Cooper Tinkers, but
Cooper Tinkers, there we go.
But Elise in the Coyote Grange is having a mini maker fair in November, the beginning of November. So, and it's free. So I'll definitely be bringing these to the mini maker fair. So it should be a good time. And I have another one of this. So I'm making repairs on that one too. So
Those are awesome.
Thank you. Cool.
Thank you very much, Dee Dee.
And that's going to get awarded a level 1 arm challenge.
All right, level 1 arm challenge.
For arms that move.
Yes. Thank you.
Armbot. Dee Dee, what's the robot's name?
I just call them dancing dolls.
Dancing dolls, got them.
Okay.
That's with capital D and a capital D, right?
Yep.
All right, very fine. Thank you, Damaris Davis, AKA Dee Dee. Thank you very much. Mike Wimble, you out there?
Nothing to demo this meeting.
Okay, Mike's working on Puck and he's got an awful lot going on. So at some point we're going to get a full report on Puck. Looking forward to that. Mike Wimble, ladies and gentlemen. Big help, smart guy, very active in the Ross discussion group. All right, next up is Jim DiNugio and Big Orange.
All right, thank you. I will be showing a video. I put together a presentation here on video, so it's all in one place. So my latest project that I prepared for this deadline specifically was Big Orange Go to Goal, using your hand, your arm. And so Orange has the Oak D camera, and using this Blaze Pose tracking with Depth AI on the camera, the Oak D, I've achieved the ability to point to a target and have it go to that target. Hopefully you can see, I'm showing a picture of myself pointing here. Just a few slides here. So just quickly, the system the AI models figure out your human pose, and from the pose, it actually, because it's a 3D camera, it can figure out the 3D location and space of your body, and then it figures out where the arms are, and then through some essentially high school, maybe early college mathematics, you can do a ray to intersect with the floor plane and find a spot on the floor where you're pointing to. And because my system already has navigation, it can find out where that is. It's mapping. It mapped using SLAM. So this is what the pose, the human pose, Blaze pose model, neural network model system looks like in action, with a 3D visualization on the right side, and the left side is the 2-dimensional overlay. Well, so there you see that. This is all happening on the Luxonis Oak D camera, the original, which I have on the robot. And I'm still discovering the different models that are available to neural network models, that is, to use on it. And this one, and I've always wanted to use this one for human pose detection. So, oh, maybe I should turn off my video here. Oops. To reduce the, how do you?
You're doing fine.
Just for bandwidth. So this is what the edge model looks like. I've chosen, they have two different versions of it, but this edge so what happens is this runs mostly on the camera hardware, which has an AI chip in it. So it runs multiple neural networks, a detection of a human pose neural network, which is fed into the best candidate to sort of score them. And on the other side, it's figuring out the landmarks. The landmarks are those where the joints are in the body. So it's putting the image through both of these, essentially detection first, and then figuring out where the leg bone is connected to the hip bone and that sort of thing, right? And then, so you end up getting just a set of numbers indicating, actually, in the mode I'm working with, it's gives you a 3D locations of the joint. So here's my implementation, sort of the prototype or the initial software test, where you see I'm using the angle from, in this case, from my arm or the shoulder. I've chosen to use just like the top of the arm to the bottom, or like the shoulder to the wrist. And if you look at this diagram, you see a little tiny blue dot. Hopefully you can see that. That's where I'm pointing on the floor. And the green line is my arm there. Here's another case where I'm actually pointing behind myself, and you see the blue dot on the floor is behind me. This is figuring out, this is testing the point intersect, or the ray intersection. There you can see I'm pointing in front, and the blue puck is in front on the graph. So now, without further ado, I'll go into the video, the demonstration, all pre-recorded today, in fact. Hopefully you can hear this. Orange, go there. Okay, I am going. I am going. And here is the same thing happening from the robot's point of view. You can see that the robot points up to sort of center the actual video, so it can see the whole skeleton and get the best pose. And then on the right here, you see that purple triangle is the goal that got set in the 2D, the top-down view. And we'll do a second one here just to show another angle, or a different run. Okay, here it is. Orange, go there. Okay, I am going. So I thought this was something I came up with when I saw this human pose capability. I thought, wouldn't it be neat to do this? And so there I'm pointing again, and even with a profile, it still sees my arm. It points up, just to get the full view. And over on the right, you see the purple square, a diamond is the goal. And this on the right side, that's all using the SLAM system and the 2D coordinate system of the of that world. And so here are the links. I'll post this, but it's using what's called the Google Media Pipe Blaze pose, and that was integrated into the OAK-D by some third party, and so it's all open source. There's a paper on the Blaze pose as well, and that is about it. Let's close this. Did that video play smoothly? I hope so.
It did. It looks awesome.
Hey, Big Orange isn't in the room there with you. Is the Jim?
Oh yeah, sorry. In fact, what was really kind of interesting right then is when I played the video, Orange heard me and started actually moving. So he and I don't know where he.
Sorry, I don't understand. LLY kind of interesting right then is when I played the
Be
video,
quiet,
Orange
Orange.
and started.
The future's going to be weird.
Yeah, because he heard what the video said, and then he started going somewhere that I was pointing. He actually saw me, I guess.
But
So here
just so he
is.
doesn't buy things on Amazon.
Yeah, if you want a picture, I can come right here. Just tell me when you got it.
Got it. Hang on, let's get down there a little further. You got to get your head down further. There you go.
Is that good?
Okay, act like you're having a good time.
All right.
All right, that's cool.
I think you already have it, Jim.
All right.
Phase 1 floor bot.
Yeah, I have phase 1 and 2 for Orange. It needs an arm now. It's a big leap. It's a big leap between phase 2 and phase 3, or I should say it's more than an arm's length.
Hey, maintenance is progress. You've got to maintain your phase 1 and 2s.
Yeah, so
All right.
Jim, just
Thank you
build
very
a
much, Jim.
Rube Goldberg system where your robot bumps into it and then ends up with something dropping into the tray.
oh, interesting.
That's
Yeah.
Jim Denude. Jim's the president of the Robotics Society of Southern California. The
Vice president this year, but yeah.
but you're always the president.
Jim, you don't really need an arm. All you need is a piece of Velcro. And you can bend something and pick it up and bring it back.
Actually, who needs the arm? Yeah, well, I want the arm, but that's true. I could, I already passed 2, so if I could just stick the Velcro to the remote and bring it back, that'll qualify. Thank you. I hope
Jim
that's
Denude and Big Orange. All right, I'm gonna do. I'm up next, and I'm gonna do 3 demonstrations. The first one, I'm going to do a phase 3 table bot. This is Buggy, and let's see how this goes. Okay, we got one. Let's put the block out here and try it again. Oops. He's dribbling it around a bit, make it exciting. Come on, come on. Oh, barely missed it. Let's try that again. Are you not entertained?
Camp, I think you should have made the box the width of the table.
I've seen some awful big shoe boxes. Come on, scoot. Oh, I'm gonna try it from the other side. One more try. Come on, Buggy. Oh, that's a phase 2. All right, I'll take what I can get. Whoops, I almost got a phase 4 there. Phase 4 is it's okay to fall off the table. The robot just still has to function when you switch him back on. Oh, almost got a phase 4 there. Come on, come on. One more turn, one more turn. Oh. One more try. There it goes. All right. Come on. One more, get it. Oh, yes, yes. It's in the bucket.
All right, that qualifies. You made it.
All right, made a phase 3. All right. So let's see now. The next thing I have is a floor box challenge. And for that, I'll share my screen. And I've basically mapped the house, not mopped the house, with the bot vac. And I'll put my GitHub on the screen here. Folks that are interested in doing this, send me an email. I think the bot vac is a great trainer for Ross. So I put my GitHub in the chat there. Basically, I've mapped the house, and here's the robot. I'm going to try for a floor bot challenge all the way around the room or all the way around the house. Let's see how this goes, okay? So here comes panels, nav 2, waypoint mode, nav goal. Let's go here. Let's go here. Let's go here. 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 Through here. And back where we started. So this is all the way around the house, okay? Nothing up my sleeves, all autonomous. So here's the robot. It's in the kitchen. That's the first waypoint. It's a second waypoint. It's a third waypoint. Fourth waypoint. I've lost count. I think that's the 5th or 6th. Anyways, he's just about to all the way around the house.
And part of that is carpet, right? So it's working on carpet.
Yeah, this is carpet. This is carpet.
So did you have?
See now when you start, well, when you start stacking a camera and a table on top of it, it doesn't work on carpet. But there's your Raspberry Pi inside driving the bot vac. And I've seen these bot vacs available on eBay, refurbished no less, for less than $100. So I think it's a great way to learn ROS. So there's Buggy the table bot and the Nito turtle. And the last thing I have to show is, and you may have already seen this before, is my Robo Magellan robot, which I'm still working on. This is Kerbit, but I kind of like this video. Like I was saying, to me, the starting place with Robo Magellan, which is a contest where the robot has to find a GPS coordinate, and there are bonus cones set along the way. You can touch the bonus cones. They give you a fractional multiplier of your time, so it decreases your overall time. But if you don't touch the goal point, the goal cone, your score is going to be your distance from the goal. So at the end of the day, it's kind of like a space mission. If you don't get back, what's the point? And so, Jim was asking where the starting point for Robo Magellan is. I'm not proud. I'll give the guy a boost here. The starting point is with the GPS, because you're given a target coordinate, and all you need to do is compare your target coordinate with the target latitude with your actual. If your target latitude is higher than your actual, you need to go north. If your target longitude is higher than your actual, you need to travel east. Here's where I actually get to the cone, but my ultrasonics kick in and drive him away from it. So that's a non-starter in robo games. I still need to do more work. But here he is coming back to the GPS cord. GPS is good for 10 or 15 feet. It puts you in the ballpark. You've got a camera in there. I've got the Pixie Cam to drive it on into the OSHA orange. But like I say, I've got a bug where my ultrasonics interrupt it. But I kind of like the way this one ends.
Now, are you using a compass, or an IMU with compass?
No, I'm just using a compass. The ultimate compass, they call it, from Adafruit. And I pipe that into my Arduino. I've got 3 Arduinos, believe it or not. One Arduino just reads the compass and tells the other one what to do. The other one drives the motors and reads the sensors. And then the third Arduino is the camera. And if the camera gets in view of OSHA orange, it's like go forward. And then I've got a bumper on the front, so when it touches it, it's supposed to stop. Like I say, the bug is that my ultrasonics is interrupting as I'm driving over there. I've actually eliminated the 2 center ultrasonics.
I don't understand. Motion or OSHA orange, it's like go forward.
So don't you have trouble with the compass being mounted?
Oh, yeah. Compass is only good for 10 or 15 feet.
Camp?
Yes.
Don't you have trouble with the compass being mounted that close to the motors?
Well, compass is the GPS is only good for 10, 12 feet anyways.
No, but the compass, you said you had a compass on it.
There you get bearing from your GPS. I say compass.
Okay.
The GPS has a bearing reading.
Okay, there are compasses that you can get to also determine your which way is which.
Well, I thought he said ultimate compass. Oh,
the product is something called the Ultimate GPS from Adafruit.
Oh, it's a GPS module.
And yes, it's a GPS module that my Arduino is reading, and obviously it gives you the latitude and longitude, but it also gives you a bearing. So as you go forward, it'll tell you if you're going, north, east, south, west, and again, I use 8 segments to meander towards my target, avoiding obstacles along the way.
But
And then I've got
it deduces that from the GPS, not from the magnetic field.
Right, so you have to be moving. You have to, GPS only can do compass direction when you're moving. So as you move, right?
Right, I understand that. Okay.
And that's it. That's all I got.
Great, cool.
Thank you. Are there does anybody else have a robot they want to show this evening?
I've got something to show. It's you could almost say robot, but let me show you what
this is George, right?
George, right?
George, I am going to add spotlight.
Okay, let's see. Do I share myself here?
Yeah, you can share your screen. And I was trying to spotlight you. There you are.
Here we go. Okay, so this is I've been working on this. This is my small CNC, which I can cut robot parts from at least plywood or wood of different kinds. So I don't think I can probably do aluminum, although I haven't tried that. But I do have it set up. You see here on the side, I do now control the router. So when the system starts up to cut something, it uses an SCR, it's a relay, a solid state relay.
it's in this box that fires up the router. And then this table down here is a pretty beefy table. And I got all these parts except for the router at the electronics flea market. Okay, so
Hey,
that,
George,
yeah,
are you telling me you've got a homebrewed CNC router here?
yes, that's what this is. I have two of
That's
them.
awesome.
This is one of them. This is my small one. Now let me show you the, let's see. This is the controller. This is the controller. Now you have to kind of look at this for a little bit to figure out what it is. But this is a box that I built. Now all of these are pieces and parts for the most part. Here's a controller. This is one of the axes. This is another axis. And then this is the one, another one for the other axis. So X, Y, and Z. This is a I believe this is a 24-volt power supply. And then here's a 5-volt supply. And here's all my busing stuff. And then this board here has 4 N35 opto isolators. Okay, because I'm really sensitive about blowing the parallel port. I use an old PC to drive this thing. And anyway, this whole thing, I have a cover for it, so it doesn't look quite so crude. But I have a fan.
Homebrewed, George, that's fine.
Yeah, but it's all homebrew, and I got all the parts, like I said, at the electronics flea market. And I don't know, I suppose the XY mount that I got, I paid $20. Couldn't believe it. I got that whole thing for $20. And I suspect I've got probably about $75 in the thing. Oh, a little thing for if anybody else is trying this sort of stuff. I found out one of my controllers wasn't quite functioning. It was jittering around and stuff. And I put a scope on it and looked. And I finally found out that I had to use a 100-ohm resistor from the parallel port to drive the 4N35 opto isolator. They say it'll work on about 330, but it didn't. But once I did that, then all the axes were working fine. So,
George, let me understand, your computer has a parallel port?
yeah, yep. This runs off of a parallel port. So,
all right, just checking that.
Yeah. Anyway, it's a fun project. Now, from that, I hope to cut some robot parts.
Thank you very much. George Taylor, ladies and gentlemen.
Does that qualify for an arm? I'd have to show it, I guess, moving.
Let's ask our certificationator, Chris Mayer.
Yeah, well, if I
see it to get it.
Yeah, if I showed it running so that it was moving, would that qualify for an arm?
I have to admit, I'm going to leave it to you because I momentarily left the room.
Oh, well, I didn't show it moving. I'll perhaps make a video of it. Let's do this legitimately. I'll make
something
a video
to work toward. Sounds good. We have show and tell every week or every month, right?
Yep. So we'll be back.
Who else has a robot to show before we close this thing out? Come on, we got one more robot out there, I'm sure. Maybe I could dig something out.
I have something I just put in the chat. Might be interesting to people. This weekend there's a hackathon all weekend. It's a NASA sponsored Space Apps Challenge, and it's worldwide basically. I've been in this before a couple of years ago, so it's a really interesting. They have like a dozen challenges. Sorry for interrupting there, but yeah, check out the link. It's in the chat.
Very cool. Thank you very much. What's going on here, Walt? Marco? Is that me sharing my screen? Oh, wait a minute. No. Marco, you're sharing your screen?
Yes, I do. That's a very old video I made in 14, I believe.
Is this your humanoid?
Yes. Yeah.
Very cool. Do you know that robot's name? It's not a it's not the Darwin.
No, no.
What year was this?
That was 2014.
Okay.
Wow, nice.
Dancing robot.
Yeah.
You should maybe get those with Damaris's robots.
I don't know if that's actually still working, but yeah, I just found it again and
Yeah, that's classic.
Stop that.
All right, very fine. Thank you very much. What else? Anybody else got a robot to show out there? I think we're kind of done here. So unless somebody's got something else, this concludes the 20th annual HBRC Challenge Phase 3. We probably had 20 robots there. I'll have to count them up. That's what I always shoot for. But we had some fun. I want to thank everybody for showing up, and I especially want to thank everybody for participating. We had some fun. So Homebrew Robotics Club, we meet the last Wednesday every month on Zoom and in person at Maker Nexus. I want to thank Maker Nexus, Al Margales, Dan Tukler, Chris Mayer, Stephen Williams. I think the next one's the HBRC business meetings, the first Wednesday. Everybody knows our website. Just Google Homebrew Robotics Club. Thus concludes the show. So now we'll branch off into random access and just hang out until security kicks us out. Thank you very much.
Thanks, Cam.
Thanks, everybody. Good night.
We had some fun. Scott, good to see you. Good show.